Alright guys, thanks for watching this. I just wanted to give you a little video because we're going pretty fast through this chapter, this unit on probability because of time constraints, and I just wanted you to be able to watch this and re-watch it just so you have a better understanding of what probability is. So I'm going to touch on a few different things today covering probability. So probability is just the likelihood or chance of an event occurring. So if something's going to happen, whether it's likely or certain or impossible, that's what probability is. And we measure it using different ways. We can use words like you see here: impossible, unlikely, as likely as not, 50-50, likely, certain. We can use numbers or fractions ranging from 0 to 1. We can use decimals, or we can use percent. I think percent is kind of the most often used, but you can use all of these to describe probability. So there's two different types of probability that we mentioned. There's experimental probability and theoretical. Experimental is just like what actually happened if you do an experiment. Theoretical is what should happen. So we compare those two, and usually when we make predictions, we make it off theoretical if you can, but not always. So here's experimental probability. This is how you write it. It's the number of times the event occurs over the total number of trials, and we'll do an example of that. And then for theoretical probability, it's similar. It's the number of ways the event can occur. Notice the key difference there is can, because we didn't do the experiment, so we don't know if it does occur or not, but it should occur over the total number of equally likely outcomes, or the sample space there down at the bottom. All right? So let's have a look at a couple different situations where we might use probability. The first one, we'll talk about theoretical probability, then we'll talk about experimental probability, and lastly, what we'll do is try to make a prediction based on our experiment. So here we go. First thing is theoretical probability. So we're talking theoretical probability. And I need a pen here. So Andy, great guy, that Andy, so nice. He has 20 marbles in a bag. Of these, 9 are clear and 11 are blue. Total of 20. Sample space is 20. Find the probability of drawing a clear marble from the bag. Write your answer as a fraction, as a decimal, and as a percent. So here we're going to write it three different ways, number ways. It doesn't say we have to write it as a word, but we can if we want. So the probability is the number of ways the event can occur over the total number of equally likely outcomes. And I want to know what the probability of getting a clear marble is. And there are 9 of them. There are 9 clear. So to write that probability, I'm going to put the 9 clear marbles over the total number of marbles. My total sample space number is 20. So there's a probability of 9 out of 20. Okay? And then we can change this. We want to reduce this if possible, if you can simplify 9/20ths, but I don't think I can. So now I want to write it as a decimal, and I want to write it as a percent. To write it as a decimal, you can divide, and I'll do it over here. I'll do the division, 20 divided by 9, just so you see long division. 20 can't go into 9, so it goes in 0 times. I add my 0. 20 goes into 94 times. 4 times 20 is 80. I subtract, I get 10. I can add a 0 and bring it down. Then I go, how many times does 20 go into 100? 5 times. 5 times 20 is 100. I'm left with 0. So the decimal is this right here, 0.45. So the probability is also 0.45. And then for percent, remember to change a decimal to a percent, you just multiply by 100, and you move that decimal place over twice, and you get 45%. And that's how we can write the probability of getting a clear marble in this bag of 20 marbles as a fraction 9/20, as a decimal 0.45, and as a percent 45%. Fraction, decimal, percent, right there. So that is theoretical probability. That's what should happen. Now let's look at an experiment, something that actually happened, and it's a sports application. During skating practice, Sasha landed 7 out of 12 jumps. What is the experimental probability that she'll land her next jump? So, to find experimental probability of an event, it is the number of times an event occurs over the total number of trials. So here, we want the number of jumps landed over the number of jumps attempted. So she landed 7 of them out of 12. 7 out of 12. So the probability that she's going to land her next jump is 7/12. 7 out of 12. Or you could find it as a decimal or as a percent if you want. So that's all experimental probability is what actually happened. You have the total number at the bottom and the number of favorable outcomes on top. Okay. Now the reason we think about probability or work with probability is so that we can make predictions. That's the whole purpose of understanding probability. So we can predict what's going to happen in the future. Predict whether a stock is going to go up or down. Predict whether the basketball player is going to make the next basket. Predict whether you're going to get an A on the next test. All of those things. We want to be able to predict them. So this is how we can predict. I'll give you an example. This is the same scenario. We have Sasha. She made 7 out of 12 jumps. So the probability that she's going to land her next jump is 7 out of 12. Well, Sasha now is going to take 50 jumps, and I want to know about how many she's going to land. To do this, we can do it one of two ways. We can set up a proportion where you have 7 out of 12, the theoretical probability, over, the experimental probability, over something over 50. Just like we did for the percent applications. Now I can multiply across, cross-multiply 7 times 50, and then divide by 12. That's a really bad 50, sorry. 7 times 50 times 12, divided by 12. 7 times 50, 7 times 5 is 35. I add my 0. 350 divided by 12. And then I can change this into a mixed number. Change it back into a mixed number by dividing 12 goes into 35 2 times, 10 left over, 12 goes into 10 0 times, 12 goes into 100 7 times, 8 times? Yeah, 8 times. And I'm going to stop there. So this number is X. She should land 20.8 of her jumps. 20.8. Now, can you land 0.8 tenths of a jump? No. That's why it's about. So she should land about 20 or 21 jumps. And that's how we can use experimental probability to make a prediction, to see what's going to happen in the future. So that's all that I wanted to share with you is experimental probability, what actually happens, theoretical probability, what should happen, and then making predictions based on either theoretical or experimental probability. We can make predictions by setting up this proportion. And we're going to practice that in class, next class. Hopefully this was helpful. If not, sorry to waste your time, but you can browse the textbook, Chapter 10, Sections 1 through 5, before class. All right, I'll see you guys on Monday. Bye.